Hi, Assalamualaikum warahmatullahi wabarakatuh. In today's video, me and my group members will be presenting for project-based learning PBL Statistic. My name is Siti Asia binti Ismail, matric number AA191719. Now, let's move to the introduction. What is this PBL project is all about? This PBL project is based on Chapter 8 Statistic, Simple Linear Regression. In this PBL project, it acquires students a deeper knowledge where students learn about specific topic by responding to a complex question or problems given in the instruction. And the whole point about Chapter 8 is students need to totally understand the concept of correlation between dependent variable and independent variable. So, one variable denoted as x is regarded as the predictor explanatory, or we call it as independent variable, and the other variable denoted by y is regarded as the output, response, or dependent variable. When we want to use a simple linear regression, there is two conditions. The first one is when we want to know how strong the relationship is between two variables. In this project, we want to know the relationship between the height of a ramp and mean of distance travelled by toy car. So we use the simple linear regression. The second one is when we want to know the value of dependent variable at a certain value of independent variable. In this project, we want to know the mean of distance travelled by toy car at a certain height of ramp. Therefore, in this project, we need to apply the understanding of the concept about simple linear regression to complete the PBL project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syairah binti Muhammad Saleh with matric number AA192087. Okay, I would like to present for the fila table. So the problem statement state that the experiment aims to investigate the motion of a toy car on ramp, which to study the relationship between distance traveled by a car and the height of the ramp. So we have 4 facts, ideas, learning issues, and the action or plan resources, action plan or resources needed. So for the first fact, first the motion of a toy car on a ramp need to be investigated. Second, the increment of ramp height is consistent. Third, must use the mean formula to calculate the mean distance traveled by the toy car for each height. So we move to the next ideas. For the ideas, first learn the relationship between distance traveled by toy car and the height of the ramp. Number 2, place the toy car on the top of the ramp and release it for the first height. Then measure the distance from the bottom of the ramp to the stop. Third ideas, each height should repeat the process 3 times. Collect 10 data for the height of the ramp. Each height, so in total we have 10 data. Next, learning issues. First, what happens if the toy car is placed at the different ramp height? Number 2, what is the relationship between the distance traveled by toy car and the height of the ramp? Number 3, what is the best formula for resolving this problem? So, action plan or resources needed. We have 4 lecture videos, YouTube, statistic notes, and internet. Okay, so that's all for fila table.
Lastly, the conclusion and discussion for this PBL project. This PBL is about to discuss between the distance traveled by a toy car and the height of ramp. So, as we can see, when the height of ramp is increased, the distance of a toy car is also increased. And then the mean of each distance traveled by a toy car is determined by a total of distance divided by 3 from each height of data RAM. So in a nutshell, this PBL aims to investigate the motion of a toy car on a ramp and the relationship between distance traveled by car and height of ramp. Therefore, we are able to study the concept of correlation between dependent variable and independent variable based on the scatter graph, in which we know that dependent variable is a changes in response to another variable, which is the output value or the value to be predicted, while independent variable determines the value of dependent variable, which is the input value or variable. Besides, we are able to compute and interpret the value of correlation coefficient based on the formula in the simple linear regression. We also implement the concept of coefficient interpretation solution, where we're able to compute the expected value of dependent variable for a given value independent variable. Lastly, we can conclude that the mean distance traveled by toy car is directly proportional to the height of ramp. Hence, we know that when the height of ramp is increased, the mean distance traveled by toy car will increase. So it is proven that the coefficient of correlation in this experiment is a strong positive linear correlation, which is 0.95. The value is nearly to 1. And lastly, the objectives of this experimental are achieved.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nabil Hakim bin Marisham. My number matrix is AA190454. For today, I would like to talk about PBL task. So the statement, each group is required to set up an experiment as shown in figure 1. The experiment aims to investigate the motion of a toy car on a ramp, which to study the relationship between distance traveled by a car, cm, and height of ramp, cm. Each group is free to decide the first height of the ramp and ramp length. Please state the value of ramp length that will be used in report. Students are advised not to use the same value of the independent variable among group. Please ensure the increment of ramp height is consistent with 10 data. For the first height, place the car at the top of the ramp, let it go, and then record the distance it travels from the bottom of the ramp to where it stops. Repeat this twice more, then increase the height. Keep doing this until reach the maximum height. Calculate the mean distance traveled by a toy car for each height and put it in table 1. Note to all students are required to record the video while conducting the experiment and recording the dependent variable data for the data validation. Okay, so our toy car will be placed here, and this will be our ramp, and this will be the height of the ramp, starting from the ground until it reaches the ramp. So the distance moved beyond ramp. When the toy car hits the ground, we will start measuring it from here until where it ends. This will be our experiment setup. Okay. Question 1. Draw a scatter diagram of the mean measured distance traveled by toy car versus height of ramp using Excel. So the formula for mean is mean equals to sum of terms divided by number of terms. That will be our formula for question number 1. So this will be the table recorded data of independent and dependent variable. So ramp, my group and I, we started from 3 cm, and it keeps adding up 3 cm continuously. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Our first try, we gained for height of ramp 3 cm, we gained 6.6 cm, 5 cm, 7.5 cm, and the mean is 6.3667. Okay, so how do we gain the mean? We sum 3 of the values and divided by 3 because we tried it 3 times. So hence that will be our mean for each height of ramp. Okay, next. So for the scatter diagram, for the x-axis is height of ramp 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. And for our y-axis, mean of distance traveled by toy car centimeters 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. So this will be our scatter diagram. So I plotted the the mean of each value when we gain just now, and some of my investigations shown that the value is not consistent, and sometimes the value is high, like in height of ramp 12 where 113, and then it drops by 77.2 cm. And this among the causes is because the car will make a U-turn and come back to me. Yes. That's all from me, Nabil Hakimi bin Badri Hisham. Thank you.
Alright, I will continue for the question 2. Alright, the data obtained demonstrate a comparable conclusion on the dependency between the height of the ramp and the mean of the measured distance traveled by a toy car, as seen in the scatter figure. Okay, now to answer the question, does the scatter diagram exhibit a linear relationship? The answer is yes. The scatter diagram exhibits a linear relationship between the height of ramp and the mean of the distance traveled by the toy car. The y-axis data is obtained by changing the variables on the x-axis. So the average recorded distance traveled by the toy car will increase as the height of the ramp increase. So the ramp does not grow uniformly in a straight line at the conclusion of the changes at average value. So this happens due to the condition of the toy car. So the toy car got off the track too fast and it turned back at the height ramp of the 25 cm. So hence from here we can understand that two variables, the height of the ramp and the mean of distance traveled by the toy car, are interdependent and show the correlation between the data obtained. So here I can conclude a small change in the data, it is the height of the ramp, will affect the result of the other variables. It is mean of distance traveled by the toy car.
Assalamualaikum, my name is Nur Ilisam binti Muhammad Zaini with matrix number AA190210. So today I'll be presenting about the PBL on question 3 and question 5. So let's take a look on the question first. Calculate the linear correlation coefficient for the data, interpret the given answer. So if the question asks you to find linear correlation coefficient, first thing first, you must draw a table and put the value of x, y, x square, y square, and xy. And don't forget to sum up the total value of each value. As example, you can see over here x is equal to 165, y is equal to 1093 and 5, and so same goes to the other value. So after we have drawn the table, don't forget to draw the graph of mean of toy car travel versus height of ramp. So the The graph can be made through Excel, and we must plot the X and Y on the graph. So after we plot the graph, we have to draw the linear line to know either the linear correlation coefficient is a strong linear, perfect linear, or weak linear. After draw a table, we must use the formula to calculate the value of the value of R. So first thing first, you must calculate the SSXX. So if you can see here, I only put the value that we have find just now based on the table, and same goes to SSYY and SSXY. After we got each value, and then just put on the formula to find the linear correlation coefficient, which is R is equal to SSXY over sum of SSXX multiplied by SSYY. So as you can see here, we only put the value that we have find on the equation, and we can see that R is equal to 1.95. So we can see that the linear correlation coefficient for the data is 0.95, which is it is a strong positive linear relationship. And we can conclude that when X is increased, then Y will increase.
Okay, next we move to the question number 4. In this question, we have been asked to find the least squares regression line, sketch the line. Okay, to answer this question, there is a few steps that need to be done. Okay, the first one is we need to find the slope. The slope is denoted by beta 1 cap. The formula for slope is beta 1 cap equal to sxy over sxx. Okay, the value of sxy and sxx is we have find it in the previous question. So we just replace it the value into this formula. Beta 1 cap equal to 4784.85 over 742.5, and then we got the slope beta 1 cap equal to 6.444. The second step is to find the y-intercept denoted by beta null cap. The formula for y-intercept is beta null cap equal to y cap over beta 1 cap times x cap. So y cap is the sum of y over n, and x here is the sum of x over n. We just replace it the value into the formula, and then we got 1093.5 over 10, which is the sum of y over n, minus 6.444, the value of beta 1 cap, and x is 165 over 10. And then here, the value of y-intercept is beta null cap equal to 3.024. Therefore, the last step is to put everything into the prediction equation, which is denoted by y cap equal to beta null cap plus beta 1 cap times x. So y cap equal to, we just replace it the value that we have got in the previous step, and then we got y cap equal to 3.024 plus 6.444x. As the question asks to sketch the line, so this is the scatter graph that I have created in Excel. So the straight line here is the line that is denoted by prediction equation y cap equal to 3.024 plus 6.444x that we have got in the previous step of calculation in this question. And from this line, we can say that the regression line that is best fitted to the data of x and y of this scatter graph. And that's all for question number 4. Thank you.
Now let's take a look on the question number 5. So the question is, predict the value of mean measured distance traveled by toy car when the height of ramp is 200 cm. So on this question, here's the formula where y is the dependent response variable, b0 is a population y-intercept, b1 is population slope, and x is a independent explanatory variable. So based on the equation, we know that x is equal to 200 centimeter. And the value of population slope and also the population y-intercept, we can get it based on the equation number 4 before. And then just put the value for in the equation. And now we know that y is equal to 1291.824. Therefore, when the height of ramp is 200 centimeter, the value of mean the toy car travel is 1306.504 centimeter.